look at that 4-3 modeling worksheet real quick that you guys did for homework. And I think most of us did pretty well on looking at just writing the equation and just using your calculator. Remember the calculator steps that you use, stat, calc, you edit, you put your numbers in, when your x's and your y's in your table, and then you go to stat, calc, quad reg, and you do your regression equation. I'd like to take a second and do number 11. And in number 11, you're given a situation where you have the number of days and you have the number of tickets that were sold. So the first thing you were asked to do, and if you would do me a favor and on your calculator, go ahead and find the equation of the line of the parabola that fits the data. Go ahead and do that for me real quick. And I want that equation and I want it graphed on your calculator, and I'll get you one. So I'm just going to plug mine in here. We're going to go to stat edit, and I'm going to make sure that there's nothing in my list 1 or 2. And I'm going to simply plug in the days is 1, 2, and 4. And over here in the y's, I have 32, 64, and 74. Now, if I try to graph it, first of all, do you remember where I go to turn on the stat plot to graph it? Second y equals, right? So if I go to second y equals, maybe, there we go. Second y equals. We're going to turn that plot on, right? We're going to go, that type is the right, scatter plot's the right type. How can I listen to that? And then X list, Y list is list 1, list 2. How come when I go to graph, I don't see anything? I know Moody knows, because him and I discussed it this morning. But why don't I see the points when I went to graph? I turned it on. Because what? I didn't hear what you said. Well, it's not a lot. We're just looking for the points, right? We're just looking for the points. Where are my points? If you look at the size of the numbers, put on my desk, please. If you look at the size of the numbers, they're up at 32, 64, 74. What kind of window do I have right here? It's too small. I got to make it bigger. A quick way to make it bigger is just going to zoom stat. If I go to zoom stat, I'll be able to see it. Right? And you can see it. The problem with zoom stat is that I don't see where it hits the ground. I don't see any of that. So zoom stat works sometimes, but it's not something I encourage you because you don't see the whole parabola. So I'm going to go back to zoom standard for a minute. And how am I going to, what do I need to change to see the whole thing? The y's. The y's have to go up to at least 74. So let's go to my window and let's make my y max up to 100. Just so we can see everything. That's all I care about. And now if I hit graph, I do see them, don't I? I do. Okay, so you should, because you have to turn it on. Go to stat plot and make sure it's turned on. Once you've entered the data, you should have it turned on. You see it now? Everybody's going to help you. So everyone should do the same thing I do. Now, if I want to find the equation of the parabola that goes with it, which is part A, where do I go on my calculator again? Remember? Where do I go? Guys, tell me. How do I find the equation? Or the model? Remember, model and equation mean the same thing. Stat, calc, option 5. We're going from list 1 to list 2. That's kind of the default, so that's good. And we're going to calculate. And it gives us some numbers here. Okay? So my equation is, I'm just going to try to put these on the same, right at the same time. The equation is negative 9, or y equals negative 9x squared plus 59x minus 18. Do we agree with that? We have our A, our B, and our C. We could, if we wanted to, go into my y equals and graph it on top of it to make sure. I'm just going to double check that. Negative 9x squared, here we go, plus 59x minus 18. I'm just going to make sure it went through it. And it does. You good? All right. So that's the part A. That was what most of you did part A, but you didn't finish part B or C. So there's part A. Part B asks a very simple question. It says, use the model or use the equation to find the number of tickets sold on day 7. So we have to kind of think about it for a minute. Is day 7, is a day the X values or is it the Y values? It's the X values. So if X is the days, the number of tickets is the Y's, what can I do with the number 7 and the equation? Plug in what? Plug in what for X? 7. That's exactly what I would do. So I'm literally going to do that. I'm going to plug in a 7 for X because that is the number of days. And tell me what you get. When I plug a 7 in for X, what do I get? Something kind of weird. Negative what? Negative 46. How can I sell negative 46 tickets? That's the answer to part B.
You lose sales.
Well, maybe.
Refunds.
Refunds. You're great at thinking about great contextual situations.
The owner
I love that.
$46 worth of stuff.
So here's the problem. This model only works for a short period of time. Okay? It only works from 0 to when it stops. Where is 7? 7 is down here below, isn't it? So this model doesn't really make sense for anything past wherever it crosses here. Where does it cross here? Let's go to our table and let's figure out when it becomes negative. It looks like after day 6, it becomes negative. So maybe day 6 is like the last day they sell tickets. Okay? So this model only works for a short period of time. So that's just kind of that happens sometimes. It doesn't work all the time. Okay? If you look at my table here, we can answer the question to part C very easily because it asks you what was the when. So we're looking again for a day value, right? So we're looking for an X value. It says when was the greatest number of tickets sold? So day 1 was 32 tickets, day 2 was 64. What day was the greatest number? Day 3. And that's all you had to tell me. We're done. Because in day 3, we had 78 tickets sold. Now, some of you went and did where you calculated the maximum here. Anybody do that part, like we did in class? Perfectly okay, but when we do the vertex, what do you notice about the vertex? It was like, what kind of number? The decimal, wasn't it? And so you had to be careful because you can't have like day 3.27 or whatever it has to be, right? It's kind of weird. That's why you had to round it near day. That's why sometimes the table makes more sense there. Any more questions on the homework? Anything else you weren't sure about? I would keep this, Bradford, make sure you pick your head up for me, honey. We are really going to do some new stuff today. All right, if you would, put this away for me, okay? You're going to study this, use this to study because part of your homework tonight will be looking at those models as well. Okay? You're going to watch your recording.
Are we going to have no PQ on this?
On modeling?
Yeah.
No. You're going to have an OPQ on solving a system.
Or mechanic PQ.
If you want to work that out with her, that's fine. All right, so let's go ahead and look at our warm-up. Did everybody do this one? Number 1. Let's just do number 1 for now. We don't have to worry about 2 and 3. We don't think we have time for all of those. But let's do number 1 for sure. Okay? I want us to use the discriminant. Uh-oh, that's a big word. Do we remember what discriminant means? What is it? Good. So what letters? Tell me the letters for it. No parentheses. It's b squared. Oh, what you mean? What's yes? That's fine. B squared. Okay. Very good. B squared minus 4ac. So it's underneath the square root. So let's do number 1. Let's figure out what the discriminant is. So b squared. So a is 3, b is negative 6, and c is 4. Negative 6 squared minus 4ac. What number do I get? Negative 12. Because I get a negative number, how many real solutions do I have? 0. What would the graph of this look like? It's a parabola that does what? Does it ever cross the x-axis? No. Okay, it's not going to cross the x-axis. The parabola is going to look something like, I'm kind of guessing here, but something like that, or it doesn't ever cross. Okay? So real solutions. But guess what? It does have what we call imaginary or complex solutions. As a matter of fact, every single quadratic equation has two solutions. Every single one. They're just not always real. Okay? Did you have a question, Tim?
Is there like a formula?
This right here, remember that's a discriminant. We learned this a couple weeks ago. Okay, so the last test, right?
Yeah.
B squared minus 4ac. And if the number you get is negative, which it was here, we said that that was no real solution. But I'm going to show you what the solutions are. They're imaginary. They're complex. So we have to decide, we have to define what an imaginary number is. Okay? An imaginary number is the letter I. Okay? And the definition, this is the straight definition of it, the square root of negative 1 is I. Okay? And so we're going to rewrite negative numbers now underneath the square root in terms of I. I stands for imaginary. So Christian, make sure you're writing this down, sweetheart. This is the new stuff, okay? Oh, we never left my lunch. So I'm right down on Leo's table. I'm so sorry. So we have two examples down here. Okay? And actually, next week we're going to be practicing, and the week after next, or after Thanksgiving also, we're going to be practicing reducing these radicals. Let's see if we remember. So I have a negative underneath the square root here. And normally, like if you were not in A plus BI mode, like for my calculator right now, my mode, oh really? Oh, that was really weird. Uh-oh, where'd that go? That's my dog. But have I shown you my pictures of my new puppy yet? Sorry, I'm obsessed a little bit. All right, there it is. Okay, good. So let me just get my calculator back up. Okay, I am in my mode on my calculator. I'm in this real mode. Do you see that right here? It says real. I asked you guys to change it. But if I just typed in right now the square root of negative 4, look what happens. It says non-real answer because I have a negative underneath the square root. And we knew that. But if I change the mode of my calculator, let's change the mode. If I change the mode of my calculator to what you should have done, which is down here, to A plus BI, that is called the imaginary or it's called a complex mode. And now, if I do the square root of negative 4, and you should try this on your calculator, it's going to give us an answer. Because, let me show you why the answer is 2i. Are you okay, Russell? I'm just glad you're awake today. That's a good thing. Why is the square root of negative 4 2i? Well, let me break it down for you.
That's an I?
It's the square, that little I. It's not. The square root of 4 times the square root of negative 1. Isn't that the same thing as the square root of negative 4? I'm just splitting it apart. We know what the square root of 4 is. Square root of 4 is just 2. And now we know, according to our definition, the square root of negative 1 is I. So that's just 2i. Sure. Okay. No. That's a very good question. What happens if you get a decimal? Because the calculator does not produce radicals, does it? So if you do the second one, you're going to get some decimals. Okay? So let me show you what we need to do, Travis, because we have to be able to reduce the radical, and the calculator won't help us with that. We do know that the square root of negative 1 is I. What we don't necessarily know is what the square root of 27 is, because it's not a perfect square. Right now, would you agree that this is true? Just took the negative out, the negative 9. Are we okay with that part? So now we just have to remember how to reduce the square root of 27. This is something that you guys did back in pre-algebra, back in middle school. It's been a while, probably. So let's think about the factors of 27. I always want you to think about the prime factors. Not the prime factors, the perfect squares. So the perfect squares are 4. Let's write it down. Perfect squares are 4, 9, 16, 25, I said 9, 36,
47,
49.
49.
Okay. And there's more, well, but that's probably where we'll stop for now. Are any of these numbers, do they go into 27?
No.
9 does.
What?
Is it 9? Yeah. 9 times what is 27?
3.
Okay, so let's break it down a little bit more. We can say that this is I, square root of 9, square root of 3. Because 9 times 3 is 27, right? And what's the square root of 9? 3. So this just becomes, we usually write the number in front of the I, it's kind of a variable. So we're going to rewrite this as 3I radical 3. Now, did the calculator really help us here? Not much. Okay? But the calculator, if you did the square root of negative 27, is going to give us a decimal. What we can use the calculator for is to double check our answer. So let me show you what I mean. If I go ahead and say the square root of negative 27, I'm going to get this whole big decimal and then the I. Do you see that? If I type in what I think I reduced it to, which is 3, now where's the I button on your calculator? Have you found it yet? Find it. Okay, so second period, right? So 3I, and then the square root of 3, right? So I'm just typing in what I think I reduced it to. And if I hit enter, notice I get the same decimal. So I just check to make sure I reduced it right, that's all. So that is what the calculator is good for. Do I want you to round that, Travis? No. But can you use it to check? Okay?
Why?
The answer is 3I radical 3. But I just checked it according to the calculator. Okay? Let's try another one. Okay? Let's just see if you can try one more here for me. I want you to do the square root of negative 150. Try to reduce that radical for me. Tell me what you get. Oh well, I'll go back here. So go ahead and do that for me. Square root of negative 150. Try to reduce that. Think about what numbers go into it. Think about the perfect squares. 25 does go in it. 25 times what is 150? Good. So 25 is 6. So let's rewrite what I can. So I have the I, because I'm taking out the negative sign. I have the square root of 25, and I have the square root of 6. I agree with that. What is the square root of 25? 5. So I have 5I square root of 6. Let's just double check that that is the answer. So I can check it with the calculator. I can go ahead and say the square root of negative 150, and you're going to get some crazy decimal answer, and I get that. And then I'm going to type in what I think I reduced it to, 5I square root of 6, and I got the same thing. So I reduced it by. Okay? So we can use our calculator to verify. Pretty easy. So that's really imaginary numbers. The second thing that we need to talk about is what is a complex number. Okay? The complex number has a real part and an imaginary part. It's nothing really difficult. It's just a combination of real and imaginary parts. It's called a complex number. The imaginary part is the part that has the I in it, and the real part is just going to be a plain old number. So for example, I have negative 3 as my, this is a complex number here, negative 3 plus 5I.
Is that what we just did?
Well, no, what we just did, we dealt with imaginary numbers. Okay? Now I'm going to combine the imaginary part with the real part. I'm going to put an add or subtract between them. And that gives me an imaginary part of 5I and a real part of negative 3. That is as far as I can reduce it. I cannot combine them. You can kind of think of the I like an X. They're not like terms. So you can't combine an imaginary part and a real part together. The You just have to leave it just like this. Okay? So, let's look. Go ahead. Yeah, Eric and Tim, you guys both do that. But make sure you watch the recording, okay? Okay. So, I'd like to look at this situation with the complex number. Okay? If I have two complex numbers equal to each other, I'm going to just kind of highlight them in different colors so you can see them a little easier. I have an equation, don't I? What do you notice that I have in parts of that equation? Variables. I got x's too. So let's actually make one of those. I need to change one of them because they both can't be x's. One of them needs to be a y. So that's a typo on my part. So let me just go and change that real quick. Let's make this, hang on. There we go. Maybe. I'm trying to, hang on. All right, let me just delete it. There we go. There we go. Y. Okay. I'm just going to change it so I have a y, that's all. Because you can't have x's and y. You can't have both x's and y. This is an example of when we would use, okay? So here's our example. What we need to do here is we have the equation of complex numbers. We need to look at what is complex, or what is imaginary and what is real. So I'm going to highlight the real parts. And I'm going to, in one color, and I'm going to highlight the imaginary parts in another color. If these two complex numbers equal each other, the real parts equal each other, and the complex parts equal each other. So that's really the key here. If you have a complex equation, one complex number equals another complex number, we're going to set the real parts equal to each other, and we're going to set the complex parts equal to each other. What is y? Y is just -3. We've already solved it. There's nothing to do. We have to do a little bit of work to get x by itself, though. How do I solve this for x? What am I going to divide by? Well, I want to get x by itself. So let's be careful. When I want to get x by itself, I got to get rid of, not subtract, I'm going to divide by the 2 and divide by the I. So we're going to divide both sides by 2i. I is the square root of -1. Remember that? It's just that's just a definition. Notice the 2 i's on the left-hand side cancels out, so I'm left with just the x, which is what I wanted. I just want the x. What happens on the right-hand side? It reduces to what? -2. The i's cancel. -4 divided by 2 is just -2. So there's my answer. I'm done. Okay? So nothing really too complicated. You just have to know when you have two complex numbers, you set the real parts equal, you set the imaginary parts equal, and that's it. Okay? Pretty easy, don't you think? Nothing too hard. So far, so good? So let's look at actually adding, subtracting them. Okay? We're going to first do it by hand. And then we're going to do it using the calculator. So let's go ahead and look at the first example. I want to add those two complex numbers. What do you think we're going to combine? What can we combine? Somebody want to come sit up in the front seat right here? Get off the lot? You sure? Come on. What can I combine, Raul, in the first example? -3 and 7. Good. What is -3 plus 7? 4. So I'm going to combine the like terms. Can I combine the imaginary terms too, Bradford? So what is 5i minus 6i? Nope. Negative I. So -1i. So 4 minus I is my answer. Now, if you have a calculator, and you are in the correct mode, which you should be, I keep thinking that. There we go. I'm in A plus BI mode, which you should be too. I want you to type this in. Negative 3, if you could use the parentheses, just like you see it. Negative 3 plus 5i plus, parentheses, 7 minus 6i. And I get the same answer. So the good news is that the calculator will actually do the operations for you. Well, just double check your signs and how you plug it in. Did you do negative 3 plus 5i? Did you use 7 minus 6i? Not 7. You subtracted the 6i? I added the negative 3 and the 7, and I added the 5i and the negative 6i. Just combining the terms in hand. That's all. Okay? All right, let's try another one. This was a little bit harder without the calculator because of the what sign? The subtraction. You have to distribute that subtraction. So I would recommend, if you're going to do it without the calculator, to distribute the negative. So a negative times a negative is a positive, so I have plus 2. A negative times a negative is also another positive, so I have a plus 9i. This negative gets distributed to both. Remember that when you subtract. So now it's a matter of combining like terms. What's my answer? What's my answer? Negative 1 plus what? Sorry. Explain a lot. I agree. Double check it on the calculator. Plug it in from the very beginning. Let's see what happens. What are you confused on? Because you distributed the negative sign. A negative times a negative is a positive. It doesn't work with the other side. What do you mean? Well, a negative is in front of these parentheses. Right? And then I have negative 2 minus 9i. Oops, 9i. Let's just make sure we got the same answer. And I did. Okay? So you should be able to do it both by hand and on the calculator. This last one, if you do it by hand, I'll give you extra credit. Right, by hand? So extra credit by hand, but you can just type it into your calculator. Let me do it by hand first so I can show you, and then I'll show you on the calculator. You can type it in on the calculator to get your answer. This is multiplication. When I multiply the two binomials, how do I do that? How do I multiply binomials? Well, right? You guys remember that? Or 2 times negative 5. Outside 2 times negative 3i, negative 6i. Inside is I times negative 5, negative 5i. Give me a second, maybe. And then the last is I times, that's negative 3i squared. You got I times I. You can multiply them, you can't add them. Okay. Did you hear Moody's question? He said, I thought you couldn't combine real and imaginary numbers. That's only when adding and subtracting. You're done, right? You can't multiply. It's an excellent question. I'm going to combine like terms. And then what is I squared? Nope. Try it on your calculator. What's I squared? What's I squared? Negative 1. Well, is it? Let's see if that's true. So isn't I just the square root of negative 1? Right? And isn't this the square root of negative 1? Right? So if I multiply those two things together, what do I get? I get the square root of 1, right? Well, hang on a second. Let's just make sure. You've got negative 1 as your pattern of honor? Okay. So this is going to be negative 1. That's interesting. So negative 1. All right. So I'm going to go ahead and multiply these two things together to get 3 positive. Negative 10. Combine my like terms. So I should have gotten this. Did you guys get that when you multiply multiply the calculator? Check me. If I multiply this on my calculator, you need to be able to multiply. It's on your SOL. Okay. We need to be able to multiply. It's negative 5. Let me turn my lights. It's hard to see, I know. So I'm going to say 2 plus I. In the right mode here. So I got, let's see, 2 plus I. Oops. Plus I. There we go. And then we have negative 5 minus 3I. Really? Negative 5 minus 3I. I'm just multiplying them because no plus or minus in between. And I did get the same thing. So again, by hand is extra credit. Okay? But you can just use your calculator as long as it's in the right mode to give you the answer. Okay? All right, what I'd like to do before we're going to take a little break for about 20 minutes, I'm going to give you some problems to work on. You're not going to be able to finish it in 20 minutes. It's a little crossword, okay, that talks about complex numbers. You can use your calculator for it, and you're just going to plug it in. Now at 8:30, I'm going to stop you because we have 2 more things we need to talk about, what we call patterns of I, and then these properties we need to come back to. Okay, so I'm just going to pause you for right now. This is always on the SOL, 100% always on the SOL. So it's really important that we pay attention to this part, okay? These are called patterns of I. And what I want us to do is I'd like for you to copy this chart into your notes, and we're going to look at patterns of I, okay? So if you would, just go ahead and copy this exact thing into your notes. And we're going to look at how to simplify these things. Most likely what you would see on the SOL would be something along these lines at the bottom. Okay? If you went ahead and tried to plug the ones on the bottom into your calculator right now to try to simplify it, you're going to get some weird answers. So let's just try it to see what I'm talking about. Okay? Let's type in how do I raise something to a power again on the calculator, do you remember? A little caret button. So raise to the 73rd power. It looks weird to me. Okay? A little caret button to make clear sign. I don't know what that means. Sort of. I see an E. What does E mean? 0. But this really is 0 plus I. This would just be I. Let's try I to the 92 power. So I to the 92 power, well, that is just 1 minus 0I. Again, this looks funny to me, don't you think? And so I'm going to show you, you can use a calculator if you can recognize anything with an E means 0. So 1 minus 0I is just 1. So let me show you a different way to do it, rather than try to interpret what this is saying. If we look at our calculator, the first ones we can come up with pretty easy. What's I squared? I squared was negative 1. I to the 3rd power was negative I, okay? And then I to the 4th power is 1. All right. So let's look at that. So we have I, negative 1. So I, negative 1. What was I to the 3rd again? Negative I. Notice that I'm curling the I to make sure it's very different than the 1. That's going to be important, right? You have to distinguish. And then I to the 4th was just 1. Okay? Well, guess what? Try I to the 5th for me. You're going to notice something. What's I to the 5th? I. That's not a coincidence. The pattern starts again. I to the 6th is going to be negative 1. I to the 7th is going to be negative I. I to the 4th is going to be 1. And it's going to go again in the same pattern. I to the 9th is going to be I, negative 1, negative I, 1. Those four answers repeat over and over and over and over again. Okay? How do I jump up to the 73rd, though? Well, I could just count if I wanted to. I could say 12, I could say 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. I to the 45 is here. Didn't I count that far? Did you get what I was doing? So I counted, so I got to 45. So I figured out that's I. Maybe. It is, but how could I, rather than count every time, it takes a little while, is there a shorter way to do it? Well, I'm fine if you want to count. Okay? You want to just count? That's fine. Well, no, it's divide, actually. Okay? That's what you mean. So let me show you how I know this. Okay? If I take a power, let's say, of 10. Let's do ones that we can see. If I take 10 and I divide it by 4, why am I dividing it by 4? Because there are 4 possible answers. On your calculator, what is 10 divided by 4? What is it? 2.5. 0.5 is 2 and a half. I'm worried about the half. Okay? 1 out of 4 is a half. 2/4. So 1/2 or 2/4 is here. This is going to be 1/4. This is going to be 2 out of 4. This is 3 out of 4. And this is 4 out of 4. So I'm just looking at the decimal. I could say 0.25. I could say 0.5, 0.75, or no decimal. If I'm looking at the number, the power, and I divide that power by 4, and I get a 0.5, that puts me in this column, which means negative 1 is my answer. Let's try a different one. Let's try I to the 7th. How would I figure that one out? What is 7 divided by 4? What is 7 divided by 4? 1.75. 0.75. 0.75 is 3 out of 4, so it's in the third column. It's the same as I to the third. So I to the 7th is negative I. It's not a coincidence. Now these last numbers aren't in the right columns, okay? So just kind of treat this. These are not in the right columns. So we're not saying that they're in the right columns. They're not in the right order. So we have to do, what's 73 divided by 4? 18 point what? 25. So 0.25 is in the first column, which means the answer should be I. Good. Done. I to the 92. What's 92 divided by 4? Exactly? No decimal? No decimal means the answer is 1. What's 68 divided by 4? Is there no decimal again? So it's just going to be 1. Done. Very easy. Kept a pattern. Okay? So that's why I want you to put this in your note. Gotta put your head up, buddy. So just remember, these are my patterns. Now, what if I don't remember this I, negative 1, negative I, 1? The first 4 your calculator will do for you, won't it? You have to redo the first 4 every time. You have to just redo these. Okay? No big deal. So what I'm going to do is I'm going to give you your homework. But there is no patterns of I in your homework. So I want you to write these ones down, and then I'm going to give you 4 problems with patterns of I, and I'm going to give you some textbook homework. If you complete this, we're going to bring this back with you next week. On Monday, I'm going to do the harder ones on this, okay? It's like I think it's like 13 across, 1 down. We need to look at those as well. So keep this with you, bring it on Monday, but you have textbook homework, okay? Let me write this down. So your homework is going to be these 4 patterns of I. I want you to write these down in your notes. So you're going to do I to the 50th. not in the book yet. I'll give you 4 that are not in the book. They don't do pattern divide in the book. I to the 70th, I to the 21st, and I to the 82nd. Okay? And then you have textbook homework. So in your textbook on page 253, I want you to do 8 through 12 and 18 through 23. All. Okay? So that's your homework. And you're going to bring your complex puzzle back to class with you on Monday so we can finish it. Okay?